So hello everyone. Today our topic is chemistry of coagulation of paneer. So let's start. Now we have a casein micelles, which are little balls made up of alpha, beta, and kappa casein and colloidal calcium phosphate, acting like a mineral bridges. So kappa casein has a hairy layer on micelle surface, keeps particle apart, which means repulsion. As long as CCP is intact, the surface is charged, the micelle don't stick and the milk stays fluid. It's very important point. Read it again for more understanding. Like as long as CCP is intact, the surface is charged, and if the surface is charged, the micelles don't stick, and if they don't stick, the milk should be fluid. No coagulation happens. And when you add acid, it dissolves CCP, and the tricalcium phosphate on micelle converts into monocalcium phosphate plus soluble calcium, which bridges and leaves the micelles, and it leaves the micelles, then remove calcium from caseinate, and the calcium hydrogen caseinate loses bound calcium. जो बाउंड कैल्शियम है वो लूज़ हो गया, और उससे क्या हुआ कि केजिन का चेन बन गया, फ्री हो गया ना. कैल्शियम, what calcium does? Calcium does binding, and if calcium is removed, the chain should be free. So also the drops pH like up to 4.6, which is the isoelectric point of the casein protein. So surface charge goes to 0 at isoelectric point, and the repulsion also will be 0. No repulsion, so micelle aggregate into curd, and what it entraps? Fat and some way. Now we see the speed and type of acid. First, the citric acid. It chelates the calcium strongly, which means finer grains, softer body at same pH. It is best for chena production. Now lactic acid. It gives slightly firmer curd, which is best for paneer. Slow, well distributed dosing if we are doing, so uniform small curd particles banenge. If fast dumping, so coarse rubbery clumps banenge. So what happened at heating? So heating denatures beta lactoglobulin. Its free SH groups hooks into kappa casein via sulfyl while disulfide bond. Like we have studied, beta lactoglobulin and kappa casein linkage ties whey protein into curd, higher yield produced. So if we are doing more heat, stronger and tighter protein network after acid. Now we see the comparison of paneer and chena. Like heat before acid. So paneer should be heated, the milk should be heated 85 to 90 degrees Celsius, and for chana the milk should be heated up to 80 to 85 degrees Celsius. Coagulation temperature should be 70 to 75 degrees Celsius for paneer and 70 to 80 degrees Celsius for chena. Target pH should be 5.3 to 5.6 for paneer and 5.5 to 5.8 for chena. Acid type, like we have discussed, in paneer we use both citric and lactic acid, and in chana we use citric acid or lemon juice. Post treatment should be pressing is done in paneer and no pressing is done in chena, because we want softer body. Structure, like we have dense, cohesive and sliceable body in paneer and soft and moist body in chena. Whey protein should be higher in paneer and lower in chena. Some important questions, like in chena, why not higher than 85 degrees Celsius? Like why we do not heat more than 85 degrees Celsius like in paneer? Because at too high temperature, like above 90 degrees Celsius, the excessive whey protein casein bonding, this lead to tough body, tough curd, which is bad for sweets like rasagulla. So it is important. Second is why coagulation is done at higher pH in chena. Like coagulation is also done at about 5.5 to 5.8 pH, because at higher pH whey protein are less tightly bound. If whey protein are less tightly bound, the easier kneading for sweets. Again, it is very important, this should be understand. So thank you everyone.